Hello, this is Mike Lively at the University of Central Florida, and today we're actually going to take a little break from doing the chapter videos, and we're going to look at random deposition. This is kind of an introductory to my research at UCF, and this is kind of a foundational program which I'll build on in the future. Now, it's an interesting program. You can actually put your mouse down and roll around it as the particles are deposited on the surface. So you can see as they're deposited, randomly they go up a few pixels, and then this is just a random deposition. So you put your mouse down, you can roll it around and actually take a look at it from different angles. Actually, you can look at it from the back, which is pretty cool. And you can actually click this continual rotation button. When you do it, it will continually rotate your screen around, and you can grab that and watch it grow and even rotate it as it rotates. So there you have it. And this was all built in Adobe Flex, and we're going to go to Flex, show you how the folder structure is created, and then talk about how the graphics are made, and then talk about the source code. So we're in Adobe Flex now, and if you're not used to Adobe Flex, don't worry, because as part of the book, we actually do a whole series on Adobe Flex on the book's website on how to use it in video. That'll be coming up soon after we finish chapter 1 and 2, and right now we're looking at the basic structure of the Flex program that we have created. Now we see random deposition, and there's a bin and a release and HTML and a libs. Just ignore all those. We're going to look at the SCR folder. That's the source folder, and in that I have two folders: an assets folder, an org folder, and the actual MXML file that has all the code in it. Now I need to actually generate this folder structure, so all I have to do is right click, go new, and create a Flex project. And when you do that, you give it a name, and it will create your random deposition folder, and it's basically just going to skeleton or source code that you use to create your program from. It'll create all of this for you automatically, and then you have to add the assets folder and the PaperVision org folder. Now, in Chapter 2, the next series of videos, we show you how to get the org folder. And to do the assets folder, you basically just right-click here and hit New and hit Folder and call it Assets. Once you get that folder in there, you want to drop your logo in there. In this case, I put the UCF logo. And at that point, you will have basically I'll bring up the source code here, a source code without all the code in it. And then you have to put the code in it. And we're going to talk about the code we've created. So let's go back to design, and we're going to talk about how each one of these design elements were created. So we're in design, and the first thing I want to show you is there's two tabs up here, a source tab and a design tab. So if you're in design tab, you get the design view, and in source tab you see the source code. There it is right there. So let's go back to design, and we have a few design elements on the stage, not many. We have a canvas here that we actually put our elements into. We have a few label elements here. Let me open that up so you can see it. There we go. With my name and actually a checkbox here. And a little further on in the code, let me see if I can get to it. I'm going to open this up just a little bit more. There we go. We have the UCF logo. Now all these are actually very easy to create by using going up to the Windows tab. Let me move up here so you can see it. And you click on the Windows tab and you go to Components, and you want to basically just drag the components out to the stage that you need. So for example, if I wanted to put my logo in an image component, I just come along here and I drag an image component on the stage. And then I need to do something very important. I need to go over to something called Flex Properties. You can get that through Windows, so go to Flex Properties. There we go. And you open that up. And in Flex Properties, I can actually go to the source right here and navigate to my logo. So I'm going to click on the source, and there's my assets folder, and just click on the logo and it'll bring that right onto the stage. You see that? It wasn't that easy. So it's actually that easy in a sense to bring components onto the stage, and then you have to go in and program them on the other side if they need to be interactive. So let's move on from there. We don't need this anymore. Of course, labels are easy when you're working with labels. Essentially, all you have to do is come along here and grab a label component and drag it to the stage and type in whatever you want in it, and then you can come back to Flex Properties. Let's bring that up again. And you can change the label color, its boldness, its center, and its size. So it's that easy. So we'll move on from there. And another component, of course, was the checkbox component. So once again, you just bring a checkbox out on the stage, and you'll have to basically change it once again into Flex Properties. And also you want to do some programming, and we'll show that to you in a moment. And finally, our last component here was the canvas component, which basically in Flash you don't need this component. Everything's automatically just dropped on the stage, no problem. But basically the component set is different in Flex. So we need to throw a canvas component on the stage that we can drop all our PaperVision 3D elements into, and that's very easily done, but you will make sure you give it an instance name. And the instance name in this case was PB3 Canvas. And now we're going to go to the code view, and I'm going to show you how all this is programmed and used to make our 3D random deposition. And so let's now switch from the design to source view. And let's go through the code line by line. Now in the first part of the code you just have a few Flash imports, the Flash Display Sprite, Flash Events, and MXML Events. Then you have all your PaperVision imports. And throughout the book we'll be going into details as to which each one of these import statements means. And after import statements you have to create a viewport, scene, camera, and renderer. And this is all explained in detail in Chapter 2 of the book, the next set of videos. And basically what you're doing is you're setting up your scene so you can film it. And you can really think of PaperVision as, in a sense, as filming and projecting the scene at the same time. Here are some arrays that we have not put into the code yet. This is the height and basically the squared sigma of the system. But you do want to have a cell choice. We're going to use that and a lattice plane. And that's going to be the plane that basically our numbers are popping up on. And then a do rotate. Basically when you click you want to tell it, hey, should I rotate the screen or not? An old mouse X, an old mouse Y, and an old mouse and an old rotation X and an old rotation Y. Basically what that does, it keeps track of each click, basically where the mouse was, where the rotation was. So when you start rotating again, you can basically start off from that point. And then what you want is you want a graphics container, the thing that you'll actually be rotating. So you're going to stick your mesh into the graphics container and you're going to rotate the graphics container, not the mesh. And we start off by initializing your basic PaperVision program. Now, this will be once again discussed in detail in Chapter 2. So if you're not used to this object-oriented approach, don't worry. We're going to go through it in detail. Now at the very top of the program, it's very important to look at this application line. This is the MXML application line, and in that there's a piece of code or a little segment here called creation complete. And what that means is when your program's been created, then you want to fire this initiation function. So much just like a class in a sense, you fire that initial initiation function. And in your initiation, I'm telling you to run your initial PV3D. Now, there's actually in this initiation function, which acts like a constructor, that you actually want to set all your parameters, all your variables, and then call your methods after that. And so then in the initiate PV3D, we set up our camera, our scene, our renderer. We shift our camera back 300 pixels. We create a material, well, basically just a wireframe material, and remember this is Roy G. Biv, so its first two zeros are red, next two zeros are green, and the next two zeros are blue, so our mesh will be green. Then we stick that wire mesh into our plane, and we declare it as lat plane. So our plane's set, and then we take our plane, and using add child, we throw it into our graphics holder. And then we basically give it the old rotation numbers, just basically it knows what those old rotation numbers are, which you actually set at the beginning of the code. So in the beginning of the code, you declare these old rotation 30 and 0, and then you actually assign those down here in your initiation PV3D method. And then you add your graphics holder to the scene. So basically the mesh is added to the graphics holder is added to the scene, and it'll be the graphics holder that you rotate, not the mesh. Okay, two other things you need to do. You need to add a listener for your growth loop, which is a very simple loop. Basically, each time you randomly select a point in the grid, and then you just shift it up by a small height. And you have two more add listeners, a mouse down and a mouse up, and you actually have those methods inside there. And basically, if your mouse is down, you set do rotate to true, and if your mouse is up, you set do rotate to false. And so this is going to happen every frame per second. And the whole business side of this is the growth loop. And in the growth loop, we're going to set our renderer.render scene, camera, view. Once again, that'll be all covered in Chapter 2. You're going to randomly select a point on your mesh, and then you're going to set that point and add 10 to it. Now remember, subtraction is out and plus is in, so we're actually going to subtract 10 pixels, and we're going to use this nice little method here called geometry.vertices, and that will allow me to raise or lower the vertices of my mesh. That's a cool trick, once again, which is covered, I believe, in chapter 8 of the book. And here's my do rotate. So if rotate is true, then you'll do a rotation X and a rotation Y based upon your mouse position. If it's false, then you want to see if our checkbox is checked. If it's selected, then you're going to add a continual plus Y to your rotation. And then you're going to continually set that Y position. That's pretty much all there is to the code. Let's run it one more time. Okay, you're in the process of random deposition. You can click your mouse and rotate your mesh around. And you can hit continual rotation as well. And rotate as well. So I think it's pretty cool. And this is Mike Lively at UCF. I'll see you next time.